So if you're an engineer building with LLMs, this story is probably going to sound familiar. You start with LangChain, right? You chain a few things together, and bam, in just a few minutes you've got a working prototype. It honestly feels like magic. But then you try to scale it. You start adding more tools, more logic, and all of a sudden, that incredible speed feels like a trap. Your simple chain has morphed into this complex, unpredictable agent, and when it inevitably breaks, you're just left completely in the dark. This, right here, this is the core challenge we're going to tear apart today. That constant battle between speed, control, and visibility.
And this quote, wow, it just nails it. Debugging nested chains feels like spelunking through opaque call stacks. I mean, that perfectly captures that sinking feeling, right? You're trying to debug a system where the very things that made it so easy to build, those high-level abstractions, are now the exact things hiding what went wrong. It's this exact pain point that forced the LangChain ecosystem to evolve. It had to become more than just simple chains. And that's where LangGraph and LangSmith come into the picture. So let's be clear, this isn't about which tool is best. This is the story of an ecosystem growing up, getting serious, and meeting the insane demands of production-grade AI.
All right, so here's how we're going to break this all down. First up, we'll define the core jobs that each of these tools was built to do. Then, we're going to put them head-to-head, see how they stack up directly. After that, we're doing 3 deep dives, one on functionality, another on the real cost and complexity, because it's not always obvious, and a third on the ecosystem and adoption data. And to wrap it all up, we'll look to the future, at a hybrid model that's basically becoming the blueprint for top-tier agent engineering.
So to really get a grip on this whole ecosystem, you've got to think about 3 fundamental things you always need when you're building AI apps: speed, control, and visibility. Seriously, every single architectural choice you make is a trade-off between these 3 pillars. And what's cool is that each of these tools we're talking about was purpose-built to absolutely master one of them.
So here's the breakdown, and this is the really crucial part. Think of LangChain as the builder. Its whole reason for being is maximum development speed. Then you have LangGraph, which is the orchestrator. It's all about giving you total control over those complex cyclical agent workflows. And finally, LangSmith. That's the observer. It delivers the essential visibility you absolutely need to debug and monitor these things in the wild. Speed, control, and visibility. Burn that into your brain because it's the key to understanding everything else we're about to cover.
Okay, let's put them side by side now and really see how this division of labor actually works. When you line them up like this, their different jobs just become crystal clear. And again, this isn't a question of which one is better. It's all about picking the right tool for the job you're actually trying to do.
What's so great about this view is how it just cuts through the noise. Take a look at the workflow. LangChain, it's a one-way street, a simple linear flow, what we call a directed acyclic graph, or DAG. But LangGraph, that's a whole different beast. It's a full cyclical graph. It can loop, it can branch, which is absolutely essential for any kind of advanced agentic reasoning. And LangSmith, it's not even in the same category. It's the observability layer that watches over everything. Then there's state management. In LangChain, it's kind of implicit, hidden away inside components. LangGraph makes it explicit and central, and that's the secret to its power. And all of this directly leads to their use cases. LangChain for fast prototypes, LangGraph for tough, resilient agents in production, and LangSmith for the debugging and evaluation you can't live without once you go live.
All right, let's dive in. First deep dive, functionality. This is where we get into the nitty-gritty of why you can't just use one architecture for everything, why you need different tools for different levels of complexity. And really, it all boils down to one core idea: the difference between linear and cyclical execution. So LangChain is built on this simple idea of a one-way street, a forward-only pipeline. And look, it's awesome for basic RAG or a simple chatbot where it's just step A, then step B, then step C. But what happens when your agent needs to actually think, to reflect on its work and correct itself? What if it has to try a tool, see that it failed, and then intelligently try a different one? Well, that needs a loop. It needs a cycle. And LangChain's fundamental structure just wasn't built for that. LangGraph, though, it was built from the ground up for exactly this. It gives you these low-level building blocks for total control over a workflow that can loop, branch, and retry. This is what enables real self-correction and makes your agent tough as nails.
And here's how LangGraph actually pulls this off. The whole thing is basically a state machine. You've got your nodes, think of these as your tools or your calls to the LLM. Then you have conditional edges. And these are the real brains of the outfit. They're like smart routers that look at the current situation, the state, and decide what to do next. And the most important part, you have an explicit state that gets passed between every single node. This central state is the secret sauce for fault tolerance. Why? Because if you have a really long, expensive agent run and it crashes halfway through, checkpointing means you can just pick up right where you left off from the last good state. You don't have to start from scratch. For building reliable systems, this is an absolute game changer.
So the main takeaway on functionality is pretty simple. You start with LangChain for its incredible speed when you're just knocking out a prototype. But the second your agent needs to loop, think for itself, or self-correct, you have to level up your orchestration to LangGraph to get that fine-grained control. And this is key. From the very first line of code you write, you need LangSmith watching over everything, because the visibility it gives you isn't just a nice-to-have, it is absolutely mandatory if you want any hope of taming the wild, unpredictable nature of these systems.
Okay, let's switch gears and talk about cost. And I'm not just talking about your API bill. I mean the total cost of ownership. We're talking development time, the headache of maintenance, and the very real, very scary financial hit you can take when a production system is failing and you don't even know it. This is where the trade-offs get, well, they get ruthless.
And this leads us to a concept that I think every seasoned developer feels in their bones: the abstraction tax. LangChain's high-level parts are fantastic for getting off the ground fast, but they come with this hidden price tag. When something breaks, that beautiful abstraction can actually hide the real problem, leaving you digging through layers and layers of code for hours. That's the tax. You pay for that initial development speed with your time and sanity during maintenance and debugging.
Now, whenever you think about adding a monitoring tool, the first question on everyone's mind is, what's the performance hit? And this is probably the single most important fact about LangSmith. The added latency from its tracing? It's zero. None. And the way it pulls this off is by running its data collector as a completely separate asynchronous process. So what does that mean for you? It means you get complete end-to-end visibility into every single thing your application is doing without paying a single millisecond in performance penalty. You don't have to make that painful choice between knowing what's going on and keeping things fast.
So when it comes to cost, the takeaway is pretty clear-cut. LangChain and LangGraph are open source, which is great. But they come with that hidden cost of your own team's time spent wrestling with complexity and maintenance. LangSmith, yeah, it's a subscription, but you have to see it as an investment. It takes the unpredictable, potentially huge costs of debugging a system you can't see inside of, and it turns it into manageable, actionable data. And it does all that with zero performance hit.
All right, for our next deep dive, let's look at how this all plays out in the real world. The adoption numbers for the LangChain ecosystem tell this really fascinating story. It's a story of a community that started with massive, wide-open adoption and is now shifting towards something more specialized, more focused on production-grade control.
So first, let's just talk about sheer scale. LangChain's position as the front door for LLM development is, well, it's just undeniable. I mean, check out these numbers. Over 121,000 stars on GitHub, an unbelievable 90 million downloads every month. By a huge margin, it is the #1 most downloaded framework for agents. This is the massive engine that pulls developers into the ecosystem in the first place.
But this is where the story gets really interesting. Sure, LangGraph's open source community is smaller, that makes sense, but look at this piece of data. An incredible 43% of all the companies using LangSmith in production are actively using LangGraph. Let that sink in. This isn't people tinkering on side projects. This is serious, enterprise-level adoption for systems that absolutely cannot fail. It tells you that when the pressure is on and the stakes are high, developers reach for LangGraph to get the control they need.
And here's a perfect example of the real-world impact. Klarna, the huge fintech company, they built a complex AI assistant using LangGraph and LangSmith. And the result? They cut their customer query resolution time by 80%. 80! That's not some abstract improvement. That is a massive business metric that directly affects the bottom line, proven at enterprise scale.
So, the conclusion from the data is clear. LangChain is the undisputed champion of developer volume. It's the huge on-ramp that gets everyone started. But for those really demanding, absolutely mission-critical agents, the kind you see at companies like Klarna and Elastic, LangGraph is the one providing that specialized control and resilience that you just cannot compromise on.
So what's the end game here? Where's all of this heading? Well, it's all pointing to this converged blueprint for how to build elite AI agents. See, the future isn't about picking one tool over another. It's about being smart and using all three of them together in this really elegant, multi-layered stack.
And this right here is that hybrid agentic model. Think of it in layers. At the very bottom, layer 1, you've got LangChain.
You use its gigantic library of integrations, we're talking over 1,000 of them, to build your individual tools, your agent's building blocks. Then, in the middle, layer 2, that's LangGraph. It's the stateful brain, the engine that orchestrates all those tools, managing the complex logic, the loops, and making sure it doesn't fall over. And then at the very top, layer 3, and this layer is mandatory, you have LangSmith. It's that single pane of glass that gives you total visibility across the entire system for monitoring, testing, and just making sure the quality is there.
So really, this is the ultimate takeaway. LangChain builds the tools, LangGraph orchestrates the control, and LangSmith provides that non-negotiable visibility you need to scale with any kind of confidence. It's not a competition. Each tool has a clear, distinct, and perfectly complementary job to do.
So at the end of the day, this whole LangChain versus LangGraph debate, it's just the wrong way to think about it. It's not the right question. The real question, the one you need to be asking yourself, is this. Are you architecting for the speed of a prototype, or are you architecting for the resilience of a production system? Because your answer to that question, well, that's what's going to tell you exactly how you need to build your stack.